Unit 7. Today is Thursday, January 26th. With the highlighter, the phrase that you're going to hear over and over is polynomial, polynomial function. Please highlight that guy. Mine's highlight for me. Each polynomial function is going to have a degree. Put a star next to degree. That's a free point. It's going to be easy to find, but it's one of the most important things because it's going to tell you about the picture that you're going to need to draw. In addition to that, these 5 pictures will go along with the degree. Let me have you flip the page just for a second so you know where we're going to try to go. There are these 5 pieces of the puzzle, and one of them is going to get us down to. Will you go for me, Neil? Let's do this.
Is that computer touch? Is he kidding?
Oh yeah, I guess I can, but somehow it's not.
No, I mean, is the computer touch screen?
No, it's not that one.
Oh. Only reason why I asked is because I have one at home and it's
Go to example 4, please. Yes. Example 4, once you put all the pieces of the puzzle together, this is what you're going to be required to do. On page 4, what you're going to see is, or rather page 22, they're going to ask you to find, they're going to give you an equation, or they're going to give you a picture already. Once they give you the polynomial, this is the factored form, and all those words are going to come up over and over, are using the factored form or the standard form. Once they give it to you, the first thing they're going to ask you to do is, hey, what is the degree? Fortunately, that's going to be easy to find, and I'm going to give that to you in a moment. The degree, and then they'll ask you the orientation. Orientation could be a little trickier depending on how they give it to you. If they give it to you like this, it could be a little tricky to find. How many solutions? The good news is, once you know the degree, you automatically know the number of solutions. Solutions are going to have 3 names: solutions, intercepts, and roots. Why do they have the 3 names? Probably just confusion, but in the end, it's not going to be very difficult to find. Once you have to find the roots, that is the x-intercept, where does the graph hit the x-axis? Then from there, there's a certain thing you do at each one. So there's a lot of stuff, but what I want you to know is all the pieces that we're about to do, in the end, it will allow you to list these out and sketch a picture. That's the big deal. Let's see if we can get that in the first half, and that way, again, if there's some who need to try and take care of something in the second half, some you might be able to slip out because you've been attending regularly. The others, we'll see if there's time. There may not be, and again, send out a text to just to remind you that for SGI classes, I don't see students for SGI classes on the last Friday of the month. The week before Friday, I've learned in the past that that's a mistake. It's crunches, so basically in your mind you think, any other Friday, week 1, 2, 3, oh, that's cool. But that 4th one, I don't use for my class, my AR students. That's when I use it for them. So whatever you got to get done in a math class, and some of you already done in Unit 6, it would happen by the end of today. Maybe I teach in the afternoon. So really this class period. With that said, let's start it off. There you go. To find the degree, there are certain pictures that go with it. The first thing you do is help you build the picture if you had to. You won't have this when it's time to build a picture, so you won't just be able to say degree 4, oh, I'm going to just look there. You have to build it. So let's see if I can show them how to build it. Step 1, let's show them some of the equations that go with degree 1. Degree 1 is an enough space here. So I'm going to squeeze it in. I'll put it above degree 1, and the others I won't add the extra part. The equation for degree 1, you may remember it, y equals x. If you have y equals x, the picture is going to be a straight line. In that straight line, so after degree 1, I'm going to put just x. I want to put it to the 1 power, but as I go along, you'll see, oh, I get it. Here on this first one, not only is the degree 1, but the number of x-intercepts, a different color, you'll have 1 x-intercept, or 1 root, or 1 solution. So let's start putting some of these words here. I'm going to put x-int, that's an x-intercept. You have 1. You have 1 root. The same thing is called 3 different things. And you have 1 solution. what you're going to find out is the degree is going to tell you how many of those you're going to have. Because again, when you make your picture, if it's an x to the 1 power, you know it just hits the x-axis one time. There it comes. If it's degree 2, that means the largest exponent in the problem is a 2. So it's easy to find. Which one are we looking at over here? You know, I abbreviated. It should be solution. The first time I should probably write out the whole thing. Solution. Alright. Notice here, technically, this hits twice. I'm going to do a fake one so I can make it pretend like it hits twice, even though really it only hits once, but because that U hits it twice, or because the U of parabola, well, I'll explain it later. I'm going to put the third one, I'll have you put the fourth and the fifth one. When the largest exponent in the problem is a 3, it's called a cubic function, and again, the degree, if someone gave you an equation, y equals x to the third power, and say, hey, what's the degree on this? You find the largest exponent. Boom. So that's going to be a free one. And again, the degree tells you also how many roots, that is x-intercepts, are actually in the problem. Okay, so no big deal. Do me a favor, go ahead and write in the information for a quartic, or degree 4, in other words, and then quintic, I won't use, but degree 5, just like we fill in there. So far, nice and easy, which is my plan, so that when it gets tricky, at least, okay, I have degree, I can find that. I know how many roots, x-intercepts, or solutions, they're all the same thing. I have, because it goes on with the degree. How do I draw the picture? It will become a challenge. Alright, if you have that part, what you should have done, of course, is x to the 4th power, and of course, x to the 5th power. Drawing the picture, I'm going to go straight to drawing the picture, so that if you had to just sketch a picture, please sketch a polynomial of a 4th degree. What would I write? I'm going to start with the with 1, go to 2, 3, and then I'll have you try to mess around with 4, 5, and even 6, so you can see that there's a pattern. Whenever you have to draw the graph of a polynomial, you always start with 1. It starts just like that. Let me make it in red so it can match along. It starts just like that. An arrow shooting up to the right. No big deal. A 1 is easy. To make a 2, or a second 3, you start with a 1. Bless you. To get the 2 part, you go to the left. You will always be adding to the left. You'll see what I mean in a moment. The first 2, no big deal. They are going to match their partners, but the question is, how do you draw it? Here comes a 3. A 3, again, 3rd degree. Do me a favor, put a star on the 3 and the 4. Those show the most. So if you need to know the 2, 3, and 4, the most. Here it comes. You start with a 1. You back up to a 2. And then you back up to a 3. So you always start with a 1. And as long as you can back up, every time you do an extra mark, you know that you are doing a and a 3. Do me a favor, please. Draw a 4. I'll start you off with the first part of it. Draw a 4. And then after you draw the 4, we put up there. We'll draw 5, and there is no 6 up there, but we'll do the 6 that actually shows up today. Again, what is it that you're doing? You're sketching the graph of a polynomial of degree 3, degree 4, degree 5. That's what you're doing right now. 5, and then 6, you'll have to do, even though it's not there. Again, with the 4, you start with the 1, you go 2, 3, and 4. One other thing that's true is even though we're doing jagged lines, when you actually wind up doing the lines will be kind of rounded. But for our purposes, this is enough. 5, of course, starts the same. You do 2, 3, 4, 5. And then the 6. One thing I want to say, if some of you haven't noticed it, if the degree is even, it starts high and ends high. There's the 4, starts high and high, and if you did the 6, which you'll do in just a moment, it's going to start high and end high. If the degree is odd, you always start low and high. Start low and high. Start low and high. All right, let me do 6. And I think I'm going to throw one last thing on here, which is the end behavior. All right, here we go. Here comes 6. Will it let me right over there? Yes, no, yes, no, yes, well. X to the 6th power, the degree is 6. And here comes, start there, 2, 3, 4, 5, 6. Take a look. Any questions about drawing the sketch? So far, easy. Degree, they have that. Sketch, they have that. All right. You always start with the 1. This line over here, all the way to the right.
I'm going for the 6. So it starts high.
It's ultimately going to wind up starting high. But to actually draw it, you start with that last line, then you start backing up to the left. Each time you make a mark. All right, so let's see if we can do something here. Let's talk about the end behavior. This is a tricky part. Here we go. Good luck. I'm going to do an even, and then I'm going to do an odd. Here it comes. For an even, no, not yet, not yet. Sure, here it comes, here it comes. But before I do that, let's have a word of prayer. No, here it comes, here it comes. All right, here it comes. What you're going to do right here, when you get a picture and they ask you for the end behavior, you will always start kind of at the end. I'm going to do a 3 and a 4. A 3, I'm going to draw a little arrow to the left from the center of the picture. And I'm going to draw an arrow to the right from the center of the picture. What we're doing right now is called end. I'm trying to get in all of the easy ideas before it gets tricky and you have to do it all together. Here's the deal. If I go to the left of this picture, the arrow points down. Put those in. Whatever's going on there. Oh, phone. If you go to the right of the picture, the arrow.
It's going up.
Yeah. And behavior, very simple.
So.
But how you write it, you got to use you have to use infinity to do it. So here it comes. To go to the left of a picture means you're going towards negative infinity.
You mean like domain of
Let me see if I can move this up a little bit. Will it let me pull it down a little bit so I can get under it? Not there. Will it let me get down here a little bit? Okay. Here comes the answer to this one here. As x goes to negative infinity, that represents that first arrow pointing to the left.
Y goes to.
Y is pointing down. It's also going to negative infinity.
I thought it was going up.
Oh, we're looking at this one right here. So.
Oh, there's 2 different halves.
So you have to write for both halves. So again, this is where it's about to start getting like, okay, I'm not quite sure.
Yeah.
The second half, the right-hand side, as x goes to positive infinity, y is going up, so y is also going to. No. Yeah, it's just right here with the x's. X and y's. Any questions on that? I'm gonna do it again for an even. For the x's, yes. If the x's say, am I going to the left or to the right? What am I going to do from there? All right, do me a favor. I'm out of space. Try to write the end behavior for a degree 4. How do you start that? And I'm out of space. You put a line to separate it in half. From there, you draw an arrow to the left, and an arrow to the right. The last thing you do is check and see, hey, what is the arrow doing when I go to the left side of it? Oh, the arrow's going up.
Wait, so for this one, are we doing it 3 times?
No, because it's only the two arrows at the end that you're concerned about.
Oh, okay.
What's happening on this side at the arrow, and what's happening on the right-hand side at the arrow. This guy, he has a lot of stuff in the middle, but they're not concerned about the middle. Just at the very end. What's happening on this side at the arrow? Okay. Write those in, write those in.
Okay, so are they both on both sides of the equation?
Yeah, they're both on. So the only hint I'm going to give you on this one is the two arrows that go left and right, they always start the same. This left arrow represents negative infinity for the x, and this arrow represents positive infinity for the x. In other words, the top row always begins exactly the same. X going to negative infinity, and x going to positive infinity. That part you don't have to guess on. The only part you have to guess on is, well, what is y doing when I'm going to the left? Am I going up? Or am I going down?
Yeah.
Then on the second half, what is y doing? Am I going up? Or am I going down? The general rule will be this. Hey, if it's an odd one, the left side, the y is always going to go down. The right side is always going to go up. If it's an even one, the y side, the left side, the y is going to go up. And the right-hand side is also going to go up. So there's not a lot of choices out there. Your job is just to know, okay, well, what do you ask me? All right, let me write this one in, and then we'll start seeing how much we've built so far. Okay. All right, so here's the deal. On this fourth degree, and my space is limited, so I'm going to try and erase what I have here. Let's do that. The top row for the x's, the first x always goes to negative infinity. So that part is easy. The only thing that's going to make this test kind of hard is a lot of stuff to remember. The second x goes to positive infinity. What is y doing on this side, someone please? As it goes up, it goes to positive infinity. And then the second y, what does it do?
I don't know. I'm so confused.
Take a look at it, see if you're okay.
Question. From the end behavior from x-axis moving upwards and positive.
If it were to go down, they go down negative. All right, we got end behavior. We have degrees. We know how to find that. You kind of know how to sketch. So let's see first, now the official way they're going to write some of these things, which is handout example number 1. Let's see if we can make this jump. Example 1 is page 15. All right, highlighters again. Please highlight the largest exponent in this problem and write down what degree. Highlight degree because, again, like I said to you, degree is the most important part. It should be on the back table. Do me a favor, please write down the word degree and write down what the degree of this polynomial here, this guy here is. Again, if you know what you're looking for, this one's pretty easy. Over to the left. Go up one. That thing is it. Are there any extra example ones out there? You may have gone. Alright, so I'll say out loud what the degree is of this polynomial. 6 is correct. The largest exponent in the polynomial is the degree. So again, if you know what you're looking for, if they give you that form, the degree, nice and easy. Next, You don't have to. I just did. Well, I did that because some of this extra writing here, we're not gonna look at all of it, and so it might be worth putting a box around that one. Do me a favor, below that one, please sketch what that will look like.
Do we have to make it curvy, or can I still make it straight?
You can still make it straight. Sketch what the graph of a degree 6 polynomial will look like. You did it on the other page just right before, and so the key on that will be that's what I asked for. So again, sketch that. They will put one of these on here. The first thing they're going to ask you on the test question is, what is the degree? 6, everyone's good on that one, no big deal. The second thing they're going to ask you is to be able to sketch that thing, and hopefully you start it from the right and then start backing up from there. 1, 2, 3, 4, 5, 6. Any questions on the sketch?
Everybody,
Go.
clap your hands.
Please don't sing that.
Bleach, Jose.
Next thing you need to write.
Do a solid.
This is a polynomial in standard form.
Because it ends up being 0.
And again, for those,
This is called the icing. Really good on my essay.
all right.
Yeah,
So
what?
here's the deal. They'll give you standard form most of the time, but the one that they really want to give you is factored form. Whenever you hear the word factor, that means you are multiplying. So go ahead and highlight factor. Highlight it. And write multiply. That way you know once you hear factor form. Multiply. So we're trying to build all the pieces of the puzzle. If they give it to you in standard form, and this is the part on the test where I'm trying to decide whether I'm going to make them try to do it or just give them the factor form, which is the easier version of it. So we'll see. Nonetheless, we're going to skip down here. This is the factor form. This guy here is the factor form of the guy up here.
So will the 3 and this one be?
No, that's what I'm about to clarify. All right, take a look at the factored form of this up here. How do you get the degree in factored form? The answer is you look at the exponent that's on the parentheses, and then if there's something standing alone outside, it's all one unit. And what does he mean by that? Well, if we're putting in the exponents on x plus 3, since there isn't one, it's automatically a 1. His friend over here, go ahead and put him in. He's also a
1.
right. Now, the exponent on the x is just like before. It really is just a 4. And so, to get it, you just add those together.
And it's still 6.
It's still the 6, which it should be because they represent the same picture. So I'll put the 4 plus 1 plus 1. And write down factored form. Factored form is the one that we really want you to know. Because if they give it to you in standard form, technically your first job, turn it into factored form. That is the challenge. That's from last time we saw that synthetic division, which is why we may or may not do that. There's a part with decimals that we may do. All right, let's see what they have so far. They know the degree. They know how to find it right here in standard form, easy. The largest exponent. Factored form, well, now they know it's the exponent on the letters or the parentheses. Add those together, boom, they have the degree there. Okay. All right, so now let's back up to, let's see if we can go to the main page and get some other things, or should we get it right here? Nope, let's go back to page 19, or let's see the one right after that. Skip that guy, not him. We'll actually go to the page now. It's time to build it. This particular page is going to be your big example. When it's time to study for, I would say standard 1, 2, or 3, but this is standard like 2 and standard like 3 and 4. There are, I think, 5 standards on this one, unfortunately. So here it comes. Let's go ahead and build this whole thing now that we know some of the words and actually create a picture from it. Let me have you identify what the degree will be on this one. The number of solutions, I didn't quite say it. So go ahead and write that in. If you know what you're looking for, you're just about done. And it's going to be the picture's going to be the challenge of this one. All right, so here we go. Someone go ahead and say out loud what the degree is on this one.
Oh, 6.
Right.
I said it like,
Right. So here's the trick. In factored form, let's put factored on here. Factored form. In factored form, you have to add to get it. Factored form. So I can see the first one you think, oh, it would be 1, but no, this, you have to add them together. 1 plus the 2 plus the 3. If it's in factored form, yes. If it's in standard form, which sometimes they like to put out there, then it's just, you just choose that large one. Well, how can you tell the difference? Standard form, there's a plus or minus separating the terms. Factored form, there are parentheses next door to each other because they have to multiply by each other. All right, so we got degree. The part that I didn't tell you, which I kind of mentioned on this page over here, whatever the number of the degree, these little dots represent that you have the same number of solutions. So the degree and solutions are always exactly the same. I wish they didn't put orientation in between there. You can go ahead and put 6 and 6 automatically. So when I know the degree, I know how many solutions, how many x-intercepts, how many roots. Why are we putting all the 3 words? Because they often, they might ask for the solution in this case. They might ask for the x-intercept in that case. They like to ask for roots. All right, orientation. I didn't mention it before, but I'll do it now. Look at the very beginning of the problem. If there's no sign there, the orientation is positive. If at the very beginning of the problem there is a negative sign there, then the orientation is negative. So in this particular case, orientation is positive. For that one? You know what? Actually, you make a good point because that might not be. So one or the other, but I don't know if you put a minus sign or plus sign. All right, let's get the roots. The roots are where the picture. Don't draw a picture yet. That's just me making squiggles to make a point of, well, what is it that I'm saying a root is? What is it? What will it be on the picture? A root is just where the red hits the x-axis. So wherever you hit the x-axis, you are a root. You're an x-intercept. You're a solution. You're a root. You're an x-intercept. You're a solution. You're a root. You're an x. Well, I think I get it. Wherever it hits. Why is this important? Because on some of the problems, they're going to give you the picture. And they're going to say, what are the roots of the picture, of the graph? Oh, you say, oh, it looks like it's going to be a -4. Oh, it looks like it's going to be like a -2. Oh, it looks like it's going to be a 0. Well, we'll show you how to do that in just a moment. So again, these guys here are roots. These aren't the correct roots for this problem, but they are roots. So let me erase that picture over there. That's just to say, when I give you the answer for the roots, well, what is it that he's given us? Where to put the dots on the x-axis. Again, a lot of this won't be difficult. It'll just be a lot of stuff to remember. All right, let's see if we can. All right, here it comes. Hey, Thomas, what are the roots? In factored form, there's an easy way to do it. Whatever the number inside the parenthesis is, the root is the number that you would put in the place of x to make it 0. So what would I need to put in place of x to make this parenthesis 0? In -2, it's always the same number, but the opposite sign. That's why I usually put it right below it. What would I make this parenthesis equal 0?
+3.
Yeah, same number, opposite sign. Last guy? Again, a lot of stuff about it, easy stuff. How do you write these roots? You have to write them as an ordered pair because there's going to be a dot on the x-axis. So the first guy I'll write, the other ones you will write. -2, 0 is that first root. Please write down the other two roots. What some students will make a mistake on is the difference between a root and a factor. Factors trapped inside the parentheses with an x. A root is what you get when you get out of there. There's actually extra work to do to get that. I'm going to back up on the other page to show you the long way. I just want you to see the easy way. When I do this, if someone says, hey, Thomas, get the roots of these. I always know, same number, opposite sign. Same number, opposite sign.
So will it be?
Go ahead and ask. Oh, should I need to move that up somehow?
Just erase it and then write it right next to it.
Or distraction. Alright, alright, so they got the easy part. They're building this thing. They know the degree and the number of roots are the same. They know the positive orientation if there's no negative sign there. So let's see, what did I have there? I had a -2. I had a 3. And I had a 5. Because this is sort of easy so far, the test tries to make it more difficult by making you have to factor a standard form, which, again, alright, we're almost ready for this picture thing. In baseball, there is a single, there's a double, there's a triple. The same thing with polynomial functions. There's a single, there's a double, there's a triple. Here it comes. When you look at the parenthesis, the exponent will tell you if you have a single. When you look at the parenthesis, the exponent will tell you if you have a double. And when you look at the parenthesis, the exponent will tell you if you have a triple. So there we go. The root 2, is that a single, double, or triple?
Single.
Like me. It's single like Jose because there's a 1 on it. Alright. The double. Alright. The 3 is a double because again the exponent is a 2. And then the 5 is a triple. What if the exponent was a 4? They don't have a thing for that again. I would assume so, but there's no picture that goes with that one. You'll see what I mean.
Sextuple.
There you go. We got a triple there.
Oh, shut up.
Check the clock. We're near the halfway mark. All right, so here we go. We got to try and create a picture from this thing. The y-intercept, we need a calculator. All right, we need to calculate for the y-intercept. To get the y-intercept, you'll put a 0 in the place of the x's. Put a 0 here, a 0 here, and a 0 there. 0 plus 2 is just 2. 0 minus 3 is just a -3. 0 plus 5 is just a 5. Now back to where I was right before I realized I wasn't recording. Again, with the calculator, and you don't need it yet, you raise 2 to the first power. That's just 2. -3 to the second power, which is a +9. 5 to the third power, which is
-125.
It's 125, but you're using the regular number that's already in there, so that +5.
Oh, never mind.
So in short, you're going to wind up doing this problem right here. You're going to multiply those three things together to get the y-intercept. Now it's too much information, but here goes. 2 to the 1. Too much information.
TMI.
And
The hash. The hash. The hashlings.
do me a favor. Write that down, and then we'll have us punch that into the calculator. This is the, I guess, the trickiest part of all of it. 1, the 3, the 5. Write it down, write it down. And then somebody's going to punch those numbers in, and it's going to be some big number.
Oh, you want us to multiply those three?
Uh-huh. Because that's how you have to, in order to get the y-intercept, you have the 3 inside numbers, not 2,252,200. No, this tells you on the picture where would the wavy line, where would it cross the y-axis? So here it's going to start to do its thing, and at 2,000, it's where it's going to hit, which is a terrible thing. All right, y-intercept. Here's how you write it. That's probably the trickiest part. If you're confused on the y-intercept, you're not alone. All right, let's draw the picture and then back up and put in some information on the other problem. Do me a favor. Oh, I didn't tell them about the single, double, triple. I'll tell them in a second.
They don't deserve it.
Please put in your x-intercepts, your roots. Write those in. How do you write those in on the picture? -2. I just put a dot at -2. Put in the others. Put in the others. If I put in my -2, please put in your +3. And put in your -5. You're actually drawing the picture now. This is the grand finale. This is the piece that they will say on more than one. Please sketch the graph of the polynomial. You need all this stuff on the side to do it, but this is where they punch it in. All right. There's a -2. Where's the 3? And they want a -5, -3, -4, -5. So far, this should be a big deal. Put in the dot. Single, double, triple, what does that mean? Single, draw a little arrow like this, please. Double, please draw the letter U. I hope soon you can start getting the feel like this isn't hard because any of the individual pieces are hard. It's just a lot of stuff to remember to put together. Triple is going to be like the letter S. It's going to bend. It's going to bend like that. Put a dot on it. Also, so you can tell, the people who are absent today, again, just watching the video sometimes won't be enough, so try not to be absent. It's just easy to
talking to you,
get there.
Marco.
All right, here we go. All right, here we go. Let's get the picture right now. Because it has a positive orientation, and it is a 6, let me draw the 6 thing first. We knew this is a 6. 1, 2, 3, 4, 5, 6. Because I know it's a 6, the rule is this. I'm going to start my picture by starting on the left side, and I know I'm going to end my picture ending on the right. Well, what's going to be all the stuff in the middle? This is the part that a teacher needs to tell you. Here it comes. When I start on this left side, it has to go through the very first dot. So here it goes. Coming down through that 5 is the first thing I'm going to do. The question is, when I go through that 5, what's going to happen when I go through that 5? See, 5 is a triple. When this line goes through the 5, it has to bend. Let me show them what I mean. Let me see if I can get my thing right. All right, here we go. Go through the 5. See if I can make it bend like that. And I go down. Take a look at that, see if you're confused. Take a look at that, see if you're confused. All we're doing now is making this big ugly W. And to start on the W, start on the left-hand side.
Why did you do a curve, though?
Because if you're a single, double, or triple, when I go through your dot, something has to happen. The question is, what will happen? If you are a single, I just go through straight. Nothing happens. If you're a double, I will bounce on that thing. I won't even go through. It will bounce on that. And then if it's a triple, it'll go and it'll kind of bend when it goes through it. The 2 pages on the back. All right, here we go. We got to come back up now to get to this 2. Let's see. What's happening at a 2? 2 is a single. No big deal. The question is, hey, how low do I go before I turn back up? For sketching purposes, it doesn't matter. So I'm turning around now, coming back up. The 2 is a single, so I just shoot right through the 2. No big deal. All right. We need to get to this triple. I need to get to that last dot. I need to go over here and get to the last dot, but here's the problem. To cross the y-axis, you have to cross it at the y-intercept. Now, how are you going to write 2,200 and whatever? Again, what we do is we just put in a dot at the top, and we just say that this is the 2250. If it were a 3, we'd just really go through 3. So here's the deal. You draw your line, and we're going to go up through it, and now we're coming back down. When we hit the 3 is what? A double? Double means you just bounce on it. In other words, if I'm coming to that 3 to do a double, I can't see where I am. You just bounce on it. You don't go through it, you bounce on it. Again, this is a 6. It started high, it ended high, the end behavior, which I'm going to write down here in a moment. This will serve as having all the pieces that you will need on any of the other ones where they ask you to sketch the graph or describe it. It's a lot of stuff. Hey, what's the end behavior? Let's see. If I were drawing arrows, if I went to the left, to the right, as I go to the left, this thing goes up. I see that. And as I go to the right, it also goes up at the very end. So here comes the end behavior. A lot of information. The end behavior. Let's see if we put 1 or 2 up on the end behavior. Let's see. As x goes to the left, that's negative infinity. Y goes up into the air.
To infinity.
And then as x goes to the right-hand side,
Goes to infinity. Y goes to
y also
infinity.
goes up. Take a look at it, see if there's any piece on there. Very nice. All right, the end about here on the part. And did anybody write that? I hope
No.
we did. All right. Behavior. Behavior. Okay. All right. We're going to look at 2 pieces. One where we put in some of this information. The second one where we try and go backwards from the picture, and that should be enough to introduce the
I
concept.
said there's some under here and I don't.
Yes, question. All right, I'm gonna answer it. Also, if you put a X down here, that one is wrong. Compliments of Rossi. Let's see if I can get an eraser. That should be a Y.
The power of Christ.
Bless you. All right, Hope. What you got? That is me offering it to you so that you know when it's time to draw these. There's a certain thing you do at each dot based on what the exponent was when you got the original guy. In other words, hey, what are the roots? Oh, it's a -2, so 3 and a 5.
The roots
So
are
you
the
write
band on Jimmy Fallon's show.
Then over here, that's true too. Then over here, you have to decide, okay, what would happen at that? If it's a 1, you say it's a single. If there's a 2 on that guy, you say it's a double and the triple. And then I told you, well, here's what that means in picture form. A single is a straight line. A double will be a U, and a triple will be a bend. So that's me just telling you so that now, when I get to this 5, he's a triple, I know it has to bend. The 3, there has to be a U there, so if I start from the top, it bounces. If I were to start from the bottom, it'll bounce down. What you got? What you got? There, to the...
Like, it's parentheses and then that little red mark up there. There's something that I was supposed to write down.
Right here?
At the top.
This thing right here?
Yeah.
That's the 1 on this, that's the 1 power on this one. And I just circled. All right, technically to get the roots, can someone tell me what one of the roots is on example 1? For this one here? So let's start with this guy. What's the root for this factor? It's a 2. It's the same number. Well, we're going to back up to example 1 because there's an extra piece in here. Okay. On this one here, what is the root? Someone different for x plus 3? Say it again. Here comes the trick question. What is the root for the 4x to the 4th power? 4 is close. The 0 that I heard up front here is officially it. Why is it a 0? Because the root question is asking you this. What number do I put in the place of x to make this thing equal 0? Oh, a plus 2. What do I put in here to make this a 0? Oh, a minus 3. What do I put in place of x to make x a 0? Yeah. Yeah, so that's the reason, but here's what your mind should think. Whenever I get one of these where it's out front, 0 is automatically the root. A lot of information. That little piece there is what you need for the next one I'm about to try and do. Go to example 3, and what are you going to do in example 3? You're going to write down all 6 of those things. I'll show you what I mean, the degree, the orientation, the solutions. You're going to do the example 3, what we just did on example 4. So let me see if I can find my example 3.
We have an example 3. Never mind, it's right here.
Alright, page 19. So let me write some stuff down. What is it you're writing? In the end, you're going to write degree. You're going to write orientation.
I know.
Is that what's next?
How many solutions, x intercepts, and then the y-intercept, and then it's the what kind of term.
Number of solutions.
Yeah, and x intercepts, and then the roots at, y intercept at, and then do you hear me?
Yeah, okay.
It's okay, a lot of people don't hear me.
Oh. I said I wasn't paying attention.
And then you're just going to try to sketch.
Do we have to write that down for this?
Right. So all these you're trying to write down because they are the things that allow you to try and create so just these that I have on the board so far: degree, orientation, number of solutions, root, y-intercept. We're going to do this one, and then we're going to go backwards on one off the decimals, and then I think that may be enough of the pieces. Say again, please. Okay. Orientation. Okay. This one I'm going to come around in a moment to start check marking just to see what you try to write down. Can you have your other example out with you while you're trying to do it? Yes. You do not have to try this one without looking here. Now again, there's a lot of information on here. The ones that I expect you to get for sure are degree and the roots. Those two I expect. Alright, I'm going to come. Someone say out loud what the domain, what the degree is. Alright, let me bring you back. So we do these. So right now, let's put it together. Alright, back table. Alright, here it comes. The number of solutions is always the same. Orientation, positive or negative? Yeah, if it were a -2,
it would be negative.
So it's straightforward. I'm going to put a plus sign in there, even though I told someone that you could write it. The roots, what are the roots? We got a +6, we have a -1, and we have a 0. You have to write them as ordered pairs. Take a look at that, see what you wrote down. It would be 0, 0. It's -1, 0.
Oh yeah, and 0.
0, 0, is it a single, a double, or a triple?
It's triple. No, it's double. No, it's triple. Oh, 0, 0. I thought it was a 6.
-1, what is that going to be?
Single.
And 6?
Double.
Alright, take a look at that. Here comes the y-intercept. It's a trick problem. The y-intercept, you have to put a 0 in the place of the x. The 0 on x on all three of them.
Yeah, I was
0 here, 0 here, and 0 here. Here's the problem, and I heard someone say it earlier. The three numbers. 0 to the third power is just a 0. 1 to the first power is just a 1. Negative 6 to the second power
It's 36.
is a 36.
But it all ends up being a 0.
Yeah.
It all ends up being
Take a look, take a look. Yeah. Because when you get the three pieces, this middle piece is a 1, that's no big deal. That last piece is a 36 when you raise the 6 to the second power. But 0 to the third power, it's just 0.
And then you multiply them all together.
Yeah. So the hint will be if ever you have an outside thing, you don't even have to do any work. You automatically know the whole thing is going to be 0. Uh-huh.
Let's get it to
That is, when you put your the 3 points, it has to be 3. When you look up here, whatever one attaches to it is what you put there. In other words, I haven't put 0, 0 first. So I check 0, oh, it's a 3, oh, it's a triple. And then when I got to negative 1, 0, I put that second, and I looked there, oh, it happened to be a C. So there's this here, depends on what order you put that. And then you go back up and find it. Any other question? Any other question on this one? Alright, the last piece that I'm going to do is the final. It's going to be the top row. Sure, I'll do the top row. And 1 is going to be that guy there. Now, something in here we won't be able to... This extrema thing, we're not going to address extrema. And behavior, until we get a picture, you can't do anything with that. So right now, I didn't talk about leading coefficient. That's the number next to the letter that has the highest exponent. So let's say for the first one, what is the degree, someone?
4.
Yes, 4, no big deal. If it's in factored form, you add. If it's in standard form, you just pluck it off the biggest one. What is the leading coefficient on the top one? We didn't talk about it, but let's see who knows.
Why is the degree 4?
Because it's in standard form. Yeah. Standard, let me do that. Please write that in, standard, and write in factored.
So standard.
Factored you add, standard you pluck. Right. Leading coefficient is a... What number is in front of the x on the x to the 4th power on this first one? What number is in front of the x? Yeah. Now, I'm not going to be looking for this one. They just happen to have it on there. I just want you to hear it. The leading coefficient on this one is also going to be a 1. Last deal on this bottom one. What is the degree on this bottom one here in factor form? I heard 4. Let's see, there's a 1 on the first x. There's a 1 here, a 1 here, a 1 here. It is a 4. Once you put the exponent on all the separate pieces. Yeah. Alright, let me see if I can punch this one into the decimals and then have you fill in what the zeros are, the y-intercept. Do me a favor while I'm about to type that in. Do me a favor, put in what the zeros are for the factored form. This one is the one that we've worked on. This one's the one that's most famous. The factored form is the one that's most famous, so if you do that one. Alright, let's see if I can get in. I'm going to do decimals, so I'm going to put that thing in. We'll get the zeros, the y-intercept, and that is it. Zeros and y-intercept is what we need. I just need a keyboard. 0 and y-intercept is what we need.
so
You
many,
guys did well today.
taking so many cop shots and like
It's probably possibility.
zeros.
Possibility.
Still recording.
Oh, yes. Under zeros. So it's the same. Oh, this is 4. That top problem. So right here, next to this guy, these are the zeros. Let me get the y-intercept, and then I'm going to thank you. So what were the zeros? It was a negative 3.048. And a positive, same thing. And the y-intercept, let me click on that, and then that will be it. If you can type it in the decimals, you can fuck off the pictures. Write down the y-intercept. Write down the y-intercept. It's now on the board. All right. Uh-huh.
Are you saying me to
Uh-huh. Yes, please. Uh-huh. Can you do what? Yes. All right. That last part is 0, comma, negative 12. Goes in. Zeros on this one was a 0, 0. 20, 0. You're at the end. Negative 15, 0. And a 12, 0. R. Will we do this again? Yes, that's why we left some of them blank. Don't fill them all in. We'll look at some of these next time.